So, let me turn just on this for recording. So, we're going to work on this assignment primarily today, the web work. I want to be working on that, consulting with it. There's a few things in there that I think you will find challenging, if not all of it. There's a new web work. So like you were saying, can I get more practice?
Pointing.
Done.
Already there.
Oh yeah.
Wait, there's another one.
It won't open till 10 a.m.
So is this one due today?
Which one?
The 2.
Is that what it says?
It says it's due to you.
That seems like, no, I'll extend that. Would you send me, Hannah, could you send me an email just really quick, like just say web work 2 at the top. That's all.
It is 5 days from now.
And then the next one.
That one. What's the due date on that bad?
That one, next due date on that one, I think is next Monday or Tuesday. Probably next Tuesday.
It's another 5 days.
It's not too bad. It's a smaller one. It's smaller. So let's actually talk about what's on that next one. So web work 1, you already did. That was derivative basics. Web work 2, which I will extend. So I'm extending that, folks watching. I'm extending that through, what did I say? What should we do?
It says on the 8th, which I feel like could be fine.
The web work 2 says the 8th?
Yeah.
Yeah, the one. That's what I said. Like,
Oh, next Monday?
yeah, that's 5 days from now.
Yeah,
I
I
think that should be
The
fine.
3rd one's the 9th, so it's next day.
Okay, cool. I think that's
Yeah,
fine.
that's
Let's
fine.
leave it like
I
that.
don't have a problem with
That's great. Okay, so this doesn't need an extension, but web work 2 is on the product and quotient rules, and you should use those. One of these two, maybe both. There's one problem that involves both of these. And then web work 3 is very focused, and it is on higher order derivatives. So I just want to talk about that. You actually already know how to do this. It's just some notation and a simple extension. So this is going to be higher order derivatives. And all that means is keep taking derivatives of the thing. Take a derivative, you get something, take the derivative of that. That's all we're talking about here. So the first derivative is the thing you've been working on for a while. And we use the notation, so let's say I have y equals f of x. So the notation that says find that derivative is d dx f of x, or f prime of x, or dy dx, all that stuff. And then I guess the book uses d of f, derivative. The d stands for derivative. So, and like I've said a billion times, if you're not taking a derivative in something you do for the rest of the semester, you're doing it wrong. So, this is the first derivative. The second derivative is the derivative of the first derivative. And you can just keep this process going forever and ever. And the notation is this. So it's a little bit different. This 2 here, this number by the d and then by the variable underneath, that tells you how many derivatives to take, which will become clear in just a second. So that could also be f double prime. Each prime indicates take a derivative, or it's d squared dx squared. That's just notation. That doesn't mean do anything. The x isn't squared. This is purely notation to say do that critter, do that thing. So let's just do one more. The third derivative would be, I don't think we'll go much further than this. Maybe one of those problems did. That's third. So you can just see this number here tells you how many derivatives to take. Triple prime or cube. So let's do an example together. Given y equals 3x squared minus 2x plus 5, find y prime. So let's just do that together. And then if you get done with that fast, find y double prime. Take the derivative of the thing you just took the derivative of, and then I'm gonna get a little nutty here. Once we get past the third derivative, we just put the derivative level in parentheses as an exponent. So find the fourth derivative, find all these derivatives. It's gonna get easy at some point, I promise. I wouldn't torture you like this. Unless something nice was gonna happen. I'll give you a sanity check on that prime in just a minute. Bless you.
Wait, can this one go to a full?
Yeah, I was about to say, I don't.
Oh, I like that we're already there. Let's
I don't
do it.
think
Let's
that
get
was
there.
4 ways.
Oh, okay, somebody give me the first derivative.
6x
6x
minus 2.
minus 2, and then the 5
0.
goes to 0. Love
Proud
it.
moment.
Oh man, I'm so fucking proud. So beautiful. Louisa, is this looking good to you?
Yeah.
Okay, cool. Mace, what'd you get for the second one?
Does it just go to 6? You think nothing because it's 0.
Beautiful. Yeah, cool. Oh man, this is one of the
It's
greatest
0.
days of the semester. What's the derivative of 6, Louisa?
0.
Beautiful. What's the derivative of 0?
1.
What does the graph look like? So it's just a function that is flat, like this. It's just through 0. It's kind of like if this was 6, and
It's still 0.
it's still 0. And it just stays 0. So if I said to you, find the 100th derivative, you say, that guy's crazy, but there must be a catch. What's the 100th derivative?
0.
0. Never changes.
So now we can just stop after 3 basically.
You could.
Or would you want to 6?
You could, but if I asked for the 4th,
Yeah.
you wouldn't
Yeah.
stop, would you?
Yeah, no.
But we could.
That's like your-
Yeah, and once we know this, yeah.
Yeah.
Exactly. Let's do one more, and then we'll work on the homework. So this one involves the product rule. So here, I'm going to say f of x is x times e to the x. So notice how I said it, times. And in your head, you might say x e to the x, but start reading things with the operations. X multiplied by e to the x, x times product rule. So let's find the first derivative together. Try to use that notation. And what I mean by that is the derivative of something times something else is the derivative of that first something, other thing left alone, plus first thing left alone times the derivative of the second thing. That's what we're using here. What is the formula for the derivative of e to the x?
E to the x.
E to the x. Yep, beautiful. Hey, what's the 100th derivative of e to the x?
E to the x.
Oh yeah, good shit. That's right, never changes. product rule. I just wrote it out. Is that looking good, Louisa? Yeah, okay, cool. Yeah, you cool with that? And I take these derivatives. Derivative of x is what? 1. Leave e to the x alone. Plus x times e to the x. So it didn't get simpler, like the ones over there, the polynomials get simpler. We're never gonna get to a place where it's 0. Yes, sir?
If I wrote it like each individual thing in parentheses, just 1 parentheses, ex parentheses, 1x parentheses, ex parentheses, is that
Great.
Okay.
I'm happy you're using parentheses. You'll never go wrong by using too many. Yeah, you can get crazy, but they'll help you. Good job. So I would simplify this just a little, because I don't want that 1 there. It's just e to the x plus x e to the x. Let's find the second derivative. And can you do this in a slick way? So you can do it by hand, it's cool, but take a moment and see,
Just
yeah, what are you gonna say?
just take out the x.
Say that again. Pull the e to the x out?
Or I was just gonna say pull the x out of e to x.
So if I was gonna factor this, I think this is what you're saying, and maybe it's not, Mace, but the best factor that I can do would be that.
Okay.
I can't really, there's no x for this guy to get pulled out from.
Okay.
But I'm gonna recommend maybe leaving it like this.
Because that's why I mainly asked the reason with like the parentheses. Because the way I have it with the 1x in parentheses looks like you could just make that a derivative.
So you have like
Yeah.
that.
Essentially, yeah. Like each one has their own parentheses.
Oh, and you have
So
the one up.
the x in its own parentheses in my head could just be 1.
Yeah.
The way I had it written.
I'll come take a look at
Okay.
that. I'll come take a look at that. But what do we have to do here? Take just a moment, think about it. You can kind of exploit what we've already done. That might take less thinking than it seems like it would take. What's the derivative? So I got to do each part. What's the derivative of this part?
Ex.
E to the x. What's the derivative of this part?
Is it, is it product?
It's the thing I just found up here, right? So let's actually write this out. So this is the derivative of e to the x is e to the x. So that guy just comes down. Then plus the derivative of this guy. But I just found the derivative of this. So this thing here is actually just this expression. If you work it through, so the e to the x, I'm copying that down, plus I'll put it in parentheses so we can keep it. What's the derivative of x times e to the x? It's this thing that we just found. So it's e to the x plus x e to the x. Or you could use the product rule to see this. So I'll put product rule to get there. But this is x times e to the x again. So another product rule would be needed. Let me stop. You tell me how that feels. Let's just make sure we're on that. Is it feeling okay?
Yeah.
Yeah. Mace, how you feel about that?
Pretty good.
So now look, let's do something cool. Let's simplify it. So it's 2e to the x's plus x e to the x again. We can't get rid of this thing. Look at the rhythm here. So math is all about rhythms. The first derivative was e to the x plus x e to the x. The second derivative was 2e to the x.
Just increases every time.
Yeah, so what could we just take a guess? Let's just try. What guess would we have?
3ex plus xe.
There we go, and that's 100% right. Hey Mace, you're pretty good at taking these 100th derivatives. What's the 100th derivative of that thing?
100 ex plus xe to x.
Yeah, I love it. Luckily, we didn't have to do it by hand, step by step. What a waste of our precious life that would be. All right, this is WebWork 3.
Cool.
Finding just a couple levels of derivatives. So it's the same stuff you do and you get more practice doing the same stuff. All right, Let's work. I'm gonna go pee really fast, be right back. Seeing lots of green. So looking. Did you have a question, Hannah?
Yeah, do you know how to put a square root into?
I do.
Okay.
You would say, and so like, I'm happy to tell you this now, but just if you're on your own, I posted a symbol sheet by the very first how to log into WebWorks. I'll show you now.
Okay.
But if you're
What was
ever
the
like,
question?
it was how to enter square root.
Oh yeah, it's also on WebWork, like right as you before you click into any problem on the sets.
Oh, is it?
Yeah, it has like, not that it is super helpful. Like if you don't I don't know. It's very techy. Like it looks like coding almost. Because
Yeah,
it's SQRT in parentheses.
It is, definitely. So
Yeah.
this would just be square root of x. If you want to do a root, I would just recommend converting it to a power. I'm not sure how to do like cube roots without just, like that would be a cube root. I would just kind of use that notation. Fractional exponents on that. But, and you could do the same thing here, Hannah. You could put whatever your thing is to the 1/2 power. So in other words, at WebWork, that would be caret 1/2. Yeah. Yes, sir.
I just have a quick question.
Yeah.
on finishing up the rest of this problem.
Cool.
So I have the right, like written out with derivative form. I have the right.
Nice.
But
Awesome.
when it comes to foiling this,
Okay.
is it this times all that and this times all that?
Honestly, I don't even think you need to. Let's just put everything in parentheses, because WebWork will do a lot of math for you,
Okay.
and they don't say fully expanded out, so let's just cut and paste and put some shit in parentheses. So cut that and then say, yeah, exactly, paste it in there, and then next parenthesis, oh, that's already in parentheses, so solid, yeah. Let's try it. And see what happens. Yeah, yeah, good stuff. Got a feeling it's gonna do it.
You can't do that, dude.
It doesn't like
Also doesn't
something
like
up above, and I think
that
that's the only problem. So let's see, which one is
That was
this?
weird because that was green a second ago.
Yeah, I thought so too.
It was green.
Okay, so hold on. So, what? Okay, can we
Yeah,
scroll
sorry.
down a little bit? It's okay. So G is that. So it's saying,
Does this have to be not?
I think it should be this, so I think what's happening here, so, okay, let's look. So this guy here is the derivative of that piece.
Sure.
And then you left the second piece alone.
Oh.
Plus, now just copy that first piece. I think that's what's missing because you did, does that make sense?
It's in
Yeah, uh-huh. Yep, and then you're gonna have to do it down there too, but,
Yeah.
so just cut it down, just cut and fix that insides. Let's take a look. Okay, so maybe something. So it liked all that. Okay. I would hate it if they actually maybe put. You shouldn't have to put times. Do you?
No, because
No,
I've had a.
yeah.
It will usually just.
So let's just make sure we get plus. Oh, look. Oh, so this piece here, Mace, should be that.
Oh, these two should be flipped.
No. So check it out. So this piece here was the derivative of that guy.
one should.
And so we've got that. This one should actually just be the G. That's the problem. I think so. Cut and paste that piece. Oh no.
That's what I mean. Like,
Okay, so you did the derivative. Okay, wait. So it's the derivative of that. Yeah.
left alone.
Yes. Plus that times that left alone. Plus
That's
that left alone times the derivative of that. That's what I think we're. No, but that
that's the
should be that.
derivative.
24. Oh, but we gotta put that here. So I think that we don't have, so here we've got.
Yeah,
the
there's no
five.
24.
Yeah, check this out. This piece here is not that piece. Do you see what I'm
Yeah.
saying? Yeah, that's all. Pop that in and see what happens. I think it's gonna be real happy now. Boom.
Yeah. Okay, cool. Thank you. That was a little weird.
Gotcha. I think everything's still up on the board, Katya. There is a new web work that'll open up, and it's all about the stuff that I talked about at the beginning of the hour. So maybe
Okay.
check out that first part of that video. But you still have plenty to do here, so
Yeah.
so no rush. Doing okay?
Yeah, I'm trying to figure out how to input something.
Okay, well, let me help, because that can sometimes really suck.
Yeah.
Just a tip to everybody, if you end up like trying to enter something way too many times and it's not accepting it, but you think it's right, let me know. Tell me where it is, I'll come take a look, and I can usually help you out real fast.
I have this,
Okay.
and so it's asking now to put one, I don't really know how to do that exactly.
Oh, so we're doing this one here?
Yeah.
Okay.
And
So,
I've already found the
yeah, and that looks, and it likes it,
Yeah.
so. Oh, you're just trying to plug in the E to
Yeah.
this. Okay, cool. So, and I'll put a little tip up here. So literally just replace every X first. And so E cubed, and let's do a preview your answers. That can always help to see what it thinks you entered. So we're gonna, so the cubed is on the natural log, not the E for this one. So what I would do here, Hannah, is put the E cubed in parentheses next to the log. So if we just do that, I think this is gonna fix everything. And we'll just add another parenthesis. Let's try that. Okay, so now, okay,
This one could be
yeah, so let's see, what is that supposed to be? That's supposed to be x squared, so that should be, you're doing an exponent law
yeah,
wrong.
the exponent.
You, what, so you've got e squared cubed,
X.
or to the fifth, right?
I put it to the fifth because it was.
Oh,
X
that's right,
squared
I'm looking at the, so it's
The
e
fucking
cubed squared.
Cubed, yeah.
E cubed squared, you
That's
multiply,
six.
yeah, yes ma'am. I think that's the only problem there. And then everything else looks solid. Boom. Nice.
Alright.
Awesome.
Thank you.
You're so welcome.
I love this, I love web work days. I'm sure you guys all feel the same.
Yeah,
Lisa, you love web work.
It's alright.
What can I do for you? Anything? Are you rocking?
I think I'm good.
Okay, let me know.
wait, actually, my other question.
Okay, cool. Right here.
It's back in this phone. What is it with this?
Mm-hmm. Convert it to x to the 1/2.
Oh. Wait, what?
So when you have a square root, the only way you
Yeah.
can take it.
Oh, I put the 4 out in front, right? So I did x 1/4. Is that wrong?
That is wrong.
Okay.
Yeah, so I would first rewrite the problem as f of x equals 4x to the 1/2 natural log of x. Now when you do the product rule,
So
let's
that's
here,
2x. Okay.
yeah, exactly. It'll be 2x, but what's the new exponent?
1/2.
Negative 1/2. Yeah.
Okay.
Natural log of x.
And then when I put, okay, so then I'll just do that and then add it to the.
Mm-hmm. Yeah, it should like that. I mean, you could, but
Yeah, I really don't
Yeah.
even know.
there's enough. Well, I'll show you actually. Since you said that, since you revealed that fact, I'll make you see it. But let's just get the first thing right. Okay. So that the 1/2 didn't needs to be in. Do you see?
Gosh, yeah. That does help that I can see that now.
Uh
So
huh.
I didn't
Yeah,
know.
the answer preview helps so much.
So it wants me to put the 1/2 in parentheses?
Yes,
Okay.
because that's the whole exponent, and you want to keep it together. Another tip: that click the answer preview button to see what it thinks
Okay,
you're
yeah.
saying. It can really help.
Yeah, that would help.
There you go. Yeah, exactly. There you go.
I just
Now
thought
you're
I was
rocking.
getting all the answers.
Oh yeah, it can be otherwise, yeah,
Yeah.
it can be fishing in the dark or looking in the dark for your keys.
I
Yes,
don't
sir.
know exactly where I'm going wrong.
Okay.
Because I feel like I have the right.
Okay, so
I just have just an understanding of where they're going to go.
okay, so first off, that's actually I don't think that's a cubed root. I think that's 3
3
square
squared.
root
Oh,
of
okay.
x. So that's
That might
probably
be why.
first problem.
Okay.
So it's just gonna be 3x to the 1/2.
And then my second question was, I was looking over here, just at back in my notes. This equals that, but because
Correct.
there's no variable, does that not?
Well, there's a variable.
Oh, it is. Never mind. I'm sorry.
All sorts of
So
random
that's still
numbers
that's,
here.
that's
yeah,
that's
yes, sir.
okay.
Yeah,
Cool.
that's great. Katya, do you have anything? Yeah.
Do you have any
Cool.
question?
Yes, ma'am.
When there's, like, for example, like when there's a negative, do I just,
Yes, exactly what you did. Perfect. Good shit. What a great day.
So if it's sorry to bring you back.
That's okay.
So if it's not written like with it as a power or
If there's no number in the pocket, it's square root. Is that what you're asking?
yeah, but I'm just curious how you'd rate that.
So how you would write which part? I'm sorry.
Just the square root part, how it'd be rewritten.
Oh, okay. So
Because
let's.
I was looking up there at the,
Yeah.
it's just a robot. Stimulation.
Oh, it's not like a.
No. It's just
It's not that kind of
No,
roller.
no.
Don't be twisting them up in class. So let's first write out what we have, and then we had a 3, right?
Yeah.
So that's 3. I would write it like this: x to the 1/2 natural log of x.
Oh, okay. So the 3 just stays out.
The 3 stays out in
Okay.
front, and when you bring this 1/2 out in front,
But the
it'll
rule
become-
remains the same. That
Exactly.
Okay, cool.
Exactly. It'll just become 3/2 x to the
3x.
find my new exponent.
Okay.
Yeah.
Cool.
Give that a shot. Good stuff.
Thank you.
Welcome. Still good?
Yeah.
Cool.
by the way, if you're trying to put fractions up into a power, it does not like it unless you put the original thing in a fraction and then the whatever it is up top in a fraction as well. Like the exponent has to be in a fraction as well as the whole number.
Yes. Yeah, put in using
Yeah,
parentheses.
it'll try and be like 1 to the power and then over x instead of the entire thing being over the power.
Hannah just had that issue.
Yeah. It's a little bit more finicky than. I think the only nice part about the other one was that like you could like enter in the symbols with like the keypad. Other like
Yeah.
that made it a little bit easier.
I
just
guess so,
in
yeah,
terms
yeah.
of like being able to like because you can get the answers and not be able to write them down the right way.
True.
I went to submit and it's like your connection is not private.
Oh shit. Yeah. Yeah. It's weird. Our WebWorks server is
Didn't
so
like that answer, yes.
unsecured. Pretty
It
bad.
was so wrong.
I swear
Just
we're not.
crashed the
There's no
website.
phishing going on.
Couldn't handle an answer that absurd. Oh,
Now we have
Right on.
with the
Yes, ma'am.
entry.
Okie doke. Ooh, that does look fancy over there. So let's see. Oh my goodness. Okay. So that, okay. So for this, what I would recommend is put the 1 over x in its own parentheses. So it's times 1 over x. Because right now, yeah, it doesn't think that. Let's see how that changes things. So now let's see. So that's good, but see that your exponent there? This is what Mace was just talking about, I think. You want to put the whole 1/2 as its own exponent. Oh my goodness, you've got a lot of parentheses, Louisa. Okay, so we're gonna have to, I am gonna take out 2 levels. Actually, okay, let's just back up a little bit. I'm gonna take out this whole 2x to the 1/2, because that's honestly what's causing you a little bit of troubles. So, what you're wanting to say is, oh, this looks good though. It's right there. It's kind of, yeah. So it's 2x to the 1/2. So we're gonna say 2. Whoa, right there. Oh, I don't know if I even took it out. I guess I took it out. Okay. So we're gonna do 2, and then x. The 1/2 is the only thing that really needs parent. What just happened? Did I back up? Plus 2x caret, then the 1/2 goes in parentheses. Like that. And I think, so let's do preview. Now that looks right, so that's 2 square root of x times 1 over x, and that's what you're trying to say. And then the first one, there's a problem on the first one. So what were you
It's
trying to say there?
x to the
Mm-hmm. So do you see how we can fix it? Let me see if you, it's the same kind of problem. I would maybe just pull it all out and start over, because if you try to pair up your parentheses, it's gonna be brutal. It's so hard to see.
What's the times? This.
Yeah, and you don't even need times in general, but you can use it. Especially, it kind of helps see
Yeah.
that there's a multiply there, so definitely. There you go. The whole thing goes in the parentheses, the whole negative 1/2. Because that's your exponent, right? Now try that. So
Cool, awesome.
Okay, wait, also,
Yes, ma'am.
what do I do for the next part?
Replace X with 4.
Okay.
Copy, paste. Replace every X with a 4.
I think I might have gone astray.
Can I pull this over?
Yeah, absolutely.
Thanks. So first off, it looks like you're using that capital LN, which is definitely barfing on it, I think. So I think that, and then I would always just put a parentheses around the of X part. Now let's see. Okay, so that looks a little better. Let's submit and see if it's even happy with that. What? Oh,
Because the parentheses messes up with the X.
so you put the caret here, and that you don't need that with the
Okay.
square root. You just want square root of X, right? So let's try that. Okay, it's still incorrect, but it understands it at
Yeah.
least. So let's see, what were you trying to say here?
I took it as product.
Gosh, that looks okay. So I think our first part's a little barfed.
Okay.
So it looks like you actually haven't taken the derivative of the square root in the front. Let's take a look at that.
I thought that one gets left alone because it's considered to be the G.
So here it looks like you did leave the G alone, but the G was the natural log. So we need the derivative of 3 square root of X here.
Oh,
Yeah.
that was just rewritten.
Yes,
not the
yep,
okay.
yep.
Okay, cool.
Exactly, so do that part and then put
Okay.
that there and you'll be rocking.
Because there's a 1/2 in the exponent, is it just power to 0.5?
Say that last part again.
For doing the power rule with 3x to the power to 1/2, would it just be 1.5x?
In the front?
Yeah,
Yeah, it would.
and then would it be just 0.5 up top?
So what's 0.5 minus 1? Oh, yeah, see, it would be, you could just replace that with 0.5 if you wanted, yeah,
Okay.
if that's what you're saying,
Yes. That. Well, I was also just saying, does anything go back up there? Because I noticed.
Well, you still gotta take 1 away from that
Yeah.
exponent. So what is 0.5
Um,
minus 1?
Gotcha.
There you go, yeah, exactly, yeah, and it should like that.
Professor T, can I have some help entering?
Yes,
this in?
ma'am.
Didn't like it.
I have a couple of questions. Yeah, I'm pretty sure I'm doing this right. I think it just wants it in different like boxes.
Okay, let's take a look.
Is it saying,
pull a little closer? Okay.
is it saying this is G first? Like we were doing F before G originally?
No. They just wrote it in a different order.
Okay.
Notice here it's still the derivative of the top first.
Yeah.
So I would have written F prime G. This is the same thing as I wrote, just in a, they're putting the derivative second as opposed to first.
Or X cubed is still,
It's still your
F,
F of X. Yeah.
I'm pretty sure it did that.
Let's do an answer preview.
I looked and it looked like everything was like,
Okay, so let's go back down again. So it's looking for, h prime of X equals, so the derivative of the, so you're doing the you're doing backwards.
well, I think I did that, and then now I was just trying to mix them up to like find what it wanted.
So what's the derivative of the top? Cause I still don't like what I'm seeing there.
Okay, wait, the derivative of this is squared.
The
That's
whole
F.
thing. F is this whole expression. So F is x cubed plus 5x squared.
So then what's G? G
So
is,
G is that one. Yeah, G is simple, but F is x cubed plus 5x squared, so you should have a plus in there.
okay.
Yes, ma'am. That'll go in for that, yeah, exactly. And then that guy
Energy is just
left alone. Mm-hmm. Perfect. And the parenthesis there won't hurt, but it wasn't necessary.
Okay.
When you just have a single digit, it's when you want to group together a collection of symbols that you really want those. But it's okay, it should work. There you go. I think it's gonna be pretty happy.
Okay.
Yeah,
I'll do this.
yeah,
And then
good stuff.
I had a question on
Yes,
this.
ma'am.
Is this, I just couldn't tell if it was saying, is 3x like the first, cause I'm guessing it's product for the first.
It is. So you can think of this two ways. You can think of the first part as 3x, or you can just think it's 3 times the derivative of the x e to the x part. So you could just keep that 3 out in front, carry it along, and just do the derivative on that part, and multiply it by 3.
So would this be wrong?
That is not wrong at all.
Okay.
That's beautiful.
Okay, so then from this step, it's asking, so it's doing a, I think I have to find 0. Right, cause you said last class that we need to find. line.
Yeah, so here we're gonna need 2 things. So we're gonna replace, our point is 1. So, we're looking for the equation of the tangent line. Okay, so do you want me to put that up on the board?
Sure.
Did that help?
Yeah.
Okay. Thanks, Liz. Okay. Which, question is that, Hannah? 6, thank you. So in question 6, and this is derivatives 2. For 6, ask you to find the equation of the tangent line at the point A, f of A, where, and then Hannah's got A equals 1, you'll probably have, everybody will have slightly different answer. So step 1 is find the derivative. Step 2 is find the slope, m, at A, so that is just plug that into your derivative. And then step 3 is find the y coordinate. And that's just f of A, so plug A into the original function that you took the derivative of before you took the derivative. And we'll call that, let's say that's y sub 0. And so then your equation, your line, I think they give you this, is this right, Hannah?
Yeah.
And you gotta fill in the blank, okay, and then what you put in the blank is m parenthesis, you'll have to include your own x minus the a value plus the y naught value. Does that make sense?
Yeah.
Get you rolling, yeah, give it a shot, try it. It's a very important thing for us to use. Oh. Yes, sir.
So I actually figured out the top part. I didn't like the parentheses
Yeah.
around the 1.5
Yeah.
x and the 0.05.
Yeah, good work.
But now I'm a little confused on whether I just plug 5 in from here.
Yes. So this is literally, cut and paste this guy. Actually, put him back up here.
Yeah, I was just moving him up there so I could clear that.
You don't even paste, maybe just copy and paste, right?
Yeah.
It's just so that you still have it. And then put him back down there. And then you just go through, put him back here, too. And just go through and replace every x with 5.
You don't have to.
It'll be
I'm
totally happy.
so okay with doing that.
Yeah, I thought you might be.
I'm
I
completely
thought
okay
you
with
might
it.
be.
Listen. I
Yeah,
don't have to
that's
tell you
good
twice.
shit.
Do you have to put parentheses around the where?
I wouldn't do anything different than you did in the top one since it's right. Literally just every X replaced with a 5. Nothing new.
The only reason I say is because at 1.5x will turn into 1.55 without.
Wait, hold on. Let me come take a look. Oh.
See what I'm saying? Without
oh,
the separation.
Yeah. Let me see. Where's that at?
See, like right here, if I gotta be 1.55.
I kind of think it actually might. Oh, yeah, it might not know. So, yeah, maybe put the 1.5. Yeah, you're doing the right move.
Okay.
Yeah.
And then
Yeah,
5.
yeah. Yeah, and you don't need a print. That's cool. It's fine. You didn't need it on that one, but yeah, it doesn't hurt. I think you forgot your natural log of
I
5.
did.
Yes. Yeah, that was
Always something.
okay, good.
And then in parentheses ln parentheses 5 equals
Good stuff. Yeah.
plus parentheses sqrt.
Lost your 3. Just add it in front. Yeah, it's all good. All right. Should be real happy. Cool.
Okay.
Cool. How you doing? Need help here with anything? Oh, I can't help with that. I'm not good at that.
Okay, I think it like file says when I'm confused because E is in there, so not one like an exact one.
Oh, just leave it. Just carry the E around like it was a pi or anything. It's just a number. So just literally carry it. It's just 3E. I would just and maybe put that here. This just equals 3E. And there's no other way to write that.
So then that's my y0.
That's your wide 0. Mm-hmm.
So
It's gonna look weird.
yeah.
So let's write it out together.
Okay. This is what I got for basically the same thing
Mm-hmm.
for both of them.
And we can simplify that too, right? So this one here, was this
That's
your?
okay, don't have that.
Oh, it's okay. Where's your derivative? This your derivative?
Yeah.
And then this is, you plugged in the 1.
Yeah.
So look at what it becomes. You've got 3E,
Yeah.
don't need the 1, plus 3E. So that's 6E. Does that make sense?
Yeah, that makes sense.
Yeah.
So that's my M.
That's your M.
Okay, so 6E.
Yeah.
And then my
You just hit enter X because
oh,
you need a
just
variable
because it's
for the
like
line.
X. And then A is 3E. Or no, sorry. That's 1 plus 3E.
Yeah, good. That should be, it should be very happy with that. Dang, nice.
Awesome. I also got cut on this one for just entering.
Don't you kind of get
Because-
this like Pavlovian response to green after
Yeah,
doing this?
yeah.
Yeah.
It's like a finally.
Yeah.
This one, okay, now
Okay.
I messed this up, so you can't see what exactly.
Oh,
I was
good
trying-
lord.
There's a ton of parentheses, but I think the answer's right. It just like,
The
it
parentheses
only
are off.
put in,
So do
it
us.
put in the denominator only on my second.
Okay, let's look at preview. Do a preview of your answer.
See, now it's like not gonna show you where it was. I have to try to go in here, figure it out.
Oh yeah, it's not even previewing it.
Yeah.
It's really hosed.
Okay, that's
Yeah. It's still,
Oh, it's number two.
I think yeah, I can take a look and if you're, go ahead and do what you want and then I can help you out.
Okay, this is what I should show you. See how it's
Yes.
just over like,
Yes,
So
so
I'll
Nick, can we
yeah.
bring this a little closer to me, cause my old eyes, thank you.
so then I started
Yes,
going.
ma'am.
in
There
like
we go.
this.
Okay, yeah,
Trying to
yeah.
get that over everything.
So, first off, your denominator's this thing, right?
Yeah.
So let's get in here. And it looks like you've got, you really don't want this big parenthesis
Yeah.
to include that. So let's see if we can remove. Okay, so there's 4x squared squared.
Yep.
And I don't want that parenthesis there. What I want is that to include the whole top. So I want the whole top to be a thing
Okay.
together. So let's just do a preview now. Okay, we're getting a little the same. Is that the same? Wait, no, it's a little different still.
Is it, I think there's a, scroll over, I think there's still parentheses in the front four maybe. Is that one you go?
No, that one's okay, cause you do
Even though
want,
that one,
yeah, that's totally cool. I think, what was your original, actually, what was the original problem? Yeah, because the whole bottom is 4x squared.
yeah,
So you want that entire thing in
Okay.
parentheses and then squared. But what I think is that we need another parenthesis on top, because it looks like you've separated this chunk from that first part, and I think honestly another pair is going to, so let's get in here. So right there, and then one at the front. It is a lot. That looks
Okay.
way better. Yeah?
yeah.
Let's try it. It should work if all the pieces are right.
Alright.
So maybe we don't have all the pieces correctly. Oh, here, look here. You've got this x cubed plus
Oh.
5x squared. I would
Wait,
take the parenthesis to the right of the 8x and move it to the left side of 8x.
this parentheses,
The one that, yes, and then put that on the other side of that, yeah.
right here.
Yes, ma'am. Now try. Oh my god.
So now I need,
So I'm trying to do. So just a tip, these parentheses you've got for these single digits,
don't need them.
don't
Only for
need them, and they're
fractions.
just like painful to add. You got enough parentheses in here. But let's see. So let's put the one back, put one in front of the X, because it looks like it wants one, yeah, put one there. Try that. Oh my god. Okay, hold on. Can I get in?
Yeah,
here?
yeah.
Okay. I have to make this bigger. Can you like zoom in?
I don't wanna zoom in.
Bright's not bad either.
Okay.
Kills your battery, but
That's alright.
it's usually like Control Plus. There, oh yeah, you just do doing the thing. Okay, that's so much better. Yeah, we can just do it. Let's just do it. One more. Okay. All right. Let's actually just
Do it.
copy. Let's just do the whole damn thing over.
Okay.
Okay, I'll help you out, and then we'll go through. Why is it not? Why am I getting an ad for a racing
Yeah.
shop? I don't know.
Okay.
That is cheesy. Yeah, let's just enter this thing. Almost exactly like you see it. Use their parentheses, don't add more. And then a big one at the left. See how that one is also a parenthesis. That's like a bracket, so.
In front of all this.
Yeah, and you can even use the bracket symbol and it'll take that too.
That might make it less confusing.
I think it will. It kind of helps give distinguish
Right.
levels of things. Yeah.
So,
Uh,
something.
yeah. And then a big one next to the right X. Of the 8X, excuse me.
Oh,
So
big one next to the X.
Yeah, to pull, see, right, cause that guy there, that is a parenthesis you need to separate the numerator from the denominators to the right side of 8x. There you go, yes.
Oh, I got what you're saying. And that's.
I think that's gonna be, I think we're good. Okay, I gotta get in here again, alright, let's see,
Here, I can preview it.
thank you.
No,
See, it's not
gonna-
happy enough with that, okay, so, let's get out some
All
of
of
these
it.
extraneous things, like that guy. And that pair. And that one. Okay, that's all. Oh,
There's one on the end.
it's the wrong direction. Now let's try it.
Okay. It's gonna be like submitted answer 20.
Oh my God. Son of a. Okay, so hold on. We're gonna use the big bracket
Okay.
to keep things. So instead of that guy, we're gonna use that. So the square bracket. And then take that one. Yep, yep. Even having that square thing kind of helps a little, doesn't it? And then we'll do square bracket. Now let's try. Oh, in the bottom, so, yeah, okay. There's just the dangler at the end, I think we've got it. Boom,
Okay.
try,
Yay.
green.
Congratulations, you two. you guys were working on that by the time I left and when I came
Yeah.
back.
Just the parentheses too.
Significant scientific
Did not
occurring.
like that.
You just like for the rest of your life, and every green light is gonna flood your body with like.
Would you like to help me solve a nuclear
I would
problem
love
as
to,
well?
of course I would.
So I know we talked about what e to the x is, obviously. I don't think I was here when we ever talked about what to do when there's...
Oh, we did, it was in the, I was the couple videos I had just asked you to watch last weekend, so.
I did look for those, I'm not gonna lie, because I saw not this email, this one.
You go to the world class, I'll just show you where they're
Okay.
at. In the announcements, scroll down a little bit, there's some new viewing. Those
these
are the
two.
guys,
Okay,
yeah, but that's okay. So, the good news is, yeah, and then we didn't really talk much about it
Okay.
at all.
I didn't see it in the
But
lecture.
let's see. Oh, so for this one, again, just really replace every X with the letter E.
To the fourth.
Or is that what? Oh,
That's
yeah,
what I was talking about,
gotcha.
'cause I haven't
So,
experienced that yet.
so let's do Control C. I'll show you what we'll do. And then Control Paste. And now I'm just gonna go through here and, oh man, we're gonna be super smart. We're gonna just, we're gonna type E, oops. We're gonna type in parentheses E to the fourth. And I'm gonna cut and paste that. I'm gonna cut it, so then I'm
Yeah,
just
so
gonna
every
replace
letter is
every
X.
X, yep. Control X.
Okay.
So now I'm just gonna go through, replace that X. And I've got it in parentheses, so everything will be chill. So that, that, boom.
I think it might happen. Unless you.
We'll find out. We'll find out. We'll find out together, and we'll figure it out. But I think that looks kosher. Yeah. There is some. I'm like. So let's just talk about it really quick,
Yeah.
because there are some things I could do.
Sure.
Because this looks like shit, but that could become e to the 20th.
That's kind of what I was. Because I was like,
Exactly.
looking at it
Yeah.
in the terms of the computer's gonna read it. It looks like it'd be 30 e to the fourth to the fifth, but like another power on top.
Yeah, exactly. Yeah, it is. And this could become e to the 24th
Okay.
divided by e to the 4th, and you would subtract the exponent, so this could be e to the 20th.
Sure.
But we don't give a shit, because we just really want to
What
get
the
green.
answer?
We want green. We want green. Let's go!
We got green.
Thank you.
You're welcome.
So not that it's related to the problem, but if you were to like, remember we were talking about if you were to do the 100th derivative of e to the 4th, what does that look like?
Well, let's talk, I like that question, so let's talk. So, what's the derivative of a constant?
0.
So that's just a constant, there's no x in it. See, there's no
So
variable.
it's just e?
So it's just, what's the derivative of a constant? So let me graph this thing out. Yeah,
0.
0. So that's just 0 because it's not moving with x.
Okay.
There's no change.
I was just curious if when you turn that to a 0, if the e dissolutes to, like if you take away all of it altogether and it just becomes, the e also becomes a 0. In the sense where like you can't take e to the x and the e remains always, because there's a number in that and the constant is 0. Does the e also technically in itself become a constant?
The e is a constant.
Yeah. Okay.
Yes, e is a constant. E's just a number,
Okay.
like that's you can't write any other way. It's like pi.
Sure.
Yeah.
Okay. Cool.
Does that make sense?
Yeah.
Cool. Just before I forget, there's a video I'd love for you to watch before Monday, please. Highly recommend it.
Post it on World
It's in the new announcements. Yeah, it's
Okay.
from Nancy Pye.
Nancy.
Nancy
Name.
Pye.
What a name.
Yeah, she's good. She's good, but it'll get you warmed up, and it might be intense. This is. I just want to get you ready for the thing that's the hardest thing.
Cool.
So do a little warm up. Uh-oh. You're right there. You're good, Louise. Don't even move. Don't move.
There's only a few problems. I'll come back to them, but this one I came back to because I
Okay.
don't know what to use.
Okay.
Because I don't really know what it's asking.
Let's see. Oh, yeah, let me show you what to do for that one. Which one is that, Hannah?
This one's back at 7.
Number 7,
Yeah.
okay. So homework on number 7, they ask you something, the last part. They give you something like, and they say first simplify and then differentiate without the quotient rule. So since I have a fraction with a sum on top, I can break it apart. First I would do that. Then I would simplify by subtracting the exponents. And then I would just take the derivative with the power rule. So then when I do the derivative, it's going to be 6x minus 2x to the negative 2. So that's what they want you to do on that weird sounding second part of number 7. Break the fraction apart, make life good.
So I still have a question.
Okay, let's see.
Still doesn't like you, huh?
Yeah. That means including me.
Oh, it's never taken personally. All right, so let's see.
This is what I have. So it's
Okay, so 1/4. I think that's right. And then that's
this
just
one. This is 0.
uh-huh.
So I can't remember.
The x's totally cancel, so it's just 5/4.
Okay.
Now what? There you go. Yeah, that's not the derivative though.
What's the derivative of 5
So
fourths?
this is my answer, and then I find the
Yes,
derivative of
ma'am,
this.
correct.
I do not know.
Yeah, I think you do. I think you're getting tired.
Oh, that's zero, right? So,
The second part is
The
0,
second
what's the first part?
The math is winning.
or 4, like this.
Yeah, it's a constant times x. What's the derivative of a constant times x?
Gosh.
There you go, that's your whole answer. Boom. Green.
Okay, wait,
I won't leave, okay, no, it's okay.
This one, just say
Mhm.
how to start, because I don't really know what it's.
So,
start taking
take,
the derivative.
yeah, do the quotient rule. Let's do it together.
Quotient, that's where this thing. Okay.
We'll learn a different way to do that next week, but quotient rule is the only thing you can
Yeah,
do.
I don't even know I didn't think about that last time.
It's okay.
Derivative of 1, that would just be 0.
Yep.
The first x.
Awesome,
So
yes.
my whole first part just be 0.
The whole first part
Okay,
0,
okay.
yep.
So it's just gonna be -8.
Yes, ma'am. Yes, it is. Over what?
That's 2 squared.
Yep.
And can I just plug that into that?
Yeah, now just replace
Oh,
x with 1.
Okay. So basically it's like 36, so
Let's see, so your top is still -8, yeah.
36.
There you go.
Don't look at that.
Okay, I
It
won't.
won't work, but
I'll look at it. Good work.
I'm back at the lines.
Oh, back
So
to the
that's same
lines.
thing
That's
as that,
that's
right?
same thing as that.
Okay,
Yeah. That'll be problem 9 too, friends. That thing on the left side of the board when you might want to come back and check this out. That's also problem 9. Yeah, let me write number 9 up here really quick. And then I think Louisa maybe has a hand up. I can't
Not
tell.
yet.
Oh, okay, cool.
Need this for number 6 and number 9.
Yes, sir.
Can you, I mean, I know I could type it in, but I feel like I've got it right.
Well, let's take a look.
I think this is the right derivative form, but.
Okay, let's take a look. So we've got, so that's beautiful, and you copied that down. You need a plus, because you had it here,
Mhm.
but then, this is good, I'm so glad to see you using that notation. And then you copied that, and that looks really good, Mace. Yeah, that's beautiful.
How do you do those ones if you aren't given A?
So you'll have to, oh, wait, let me see, they don't?
They give you a point, so.
Oh, so you don't even have to do part 3. You've got, they give
I've
you
got the
X
Y.
naught, Y naught. Yeah, so they give you the A and the Y naught. They've given you the A and the Y naught.
So
part.
I just had to find
Slope at
4.
4. Yes. Yes, ma'am.
In fact, it did like the answer.
Very good. Very good. definitely work some more on Monday. I will talk a little bit about what Nancy Pye will tell you over the weekend. We're gonna ease our way into that. We're gonna really hit it hard on Wednesday. But we'll work more on this stuff together on Monday. Both those, this and the next assignment.
It's not liking my answer.
Uh-oh. Let's take a look.
You could do the slope. Okay. I'm good with that.
So can I see that derivative?
You did not, you used the, I wish this were the quotient rule. Yeah.
Oh, I forgot.
Sorry, I'm not laughing at you.
It's all good, no, it happens to everybody, you take the derivative of the top and the derivative of the bottom and like, wish to God that was it. All right, I'm ending this recording here.